Okay, so what we're going to do now is we're going to come to the very first question set for paper 3, which is only for HL, and it's essentially the math with some theory thrown in. Okay, so this here is only 15 marks, means it's very, very short. Okay, so hopefully this video shouldn't take too long. All right, so the first thing I'm going to do is read through the questions, and then we're just going to go through the answers step by step. Okay, that's all we're going to do. Nice and handy, nice and easy. Okay, so note that widgets and pidgets are imaginary products. So in a country of Burbia, the demand and supply of widgets, remember we're just doing demand here, so we're not too worried about the supply, are given by the functions. We're only going to look at the demand, which is QD, quantity demanded, the amount that people bought, which depends on prices, equals 249 minus 4p. Okay, so as we can see, the amount that people buy depends on prices. Now the first question is simply a bit of theory. Okay, so the demand curve is drawn under a certain assumption of ceteris paribus. Okay, which means other things equal, nothing else is changing. That's what that means. Okay, so it says, using an example, outline why the assumption of ceteris paribus is necessary when analysing the effect of a change in price on the quantity demanded. So what you need to write down for this question, okay, is that this means that a change in any of the non-price determinants of demand. Well, what are they? Such as a change in income or a change in tastes and preferences, right, may distort the effect of a change in price, meaning that the impact of a change in price alone cannot be determined unless other factors are changing. Right, so we know from the law of demand that as price rises, quantity demanded falls, okay? But let's say at the same time, without a ceteris paribus assumption, income quadruples. Well, as price rises, because income quadruples, and that's the demand curve shifting outwards, that could mean that we could incorrectly assume, because there's two things happening at the one time, price is rising and income is quadrupling, that an increase in price causes an increase in quantity demanded. We have to measure a change in one thing at a time, and that's essentially what ceteris paribus means. It means that we can't determine the effect that a change in price has on quantity demanded unless nothing else is changing. Okay, I am trying to keep it short, I swear. Now forgive me, there'll be a bit of fiddling around here with papers and stuff. I need to make sure you guys can see it. Right, so in Ruritania, the demand for butter is given by the function QD equals 420 minus 19p. And what I've got here now is I've got my own set of cheat notes here so I can make sure I'm not doing something silly on camera. Okay, so it says where QD is the quantity of butter demanded per year in millions of kilograms. Remember that. And price is the price of butter in dollars per kilogram, dollars. So calculate the quantity of butter demanded per year when price per kilogram is $7. Well, the thing is, how do you calculate quantity? Well, you calculate quantity, right, by using the equation that was given to us here in the question. Okay, so as you can see up here, the quantity demanded, the amount that people buy, is determined by 420 minus 19p. Okay, so now what we're going to do here is I'm going to write down p equals $7, a very unusual dollar symbol. So quantity demanded, the amount people buy, is 420 minus 19, and instead of price I'm going to put in 7. So quantity demanded equals 420, and then if you get out your calculator, and I will do that just on camera so you can see, and you go 19 times 7 equals 133, and we can see that, so I'm going to go minus 133, and then all you have to do is 420, and I'll do this here, minus answer minus 133 equals 287. I hope, and you can see that there. So quantity demanded at a price of 7 is 287. Now, is that the answer? Well, that's the numerical answer, but we're not finished. Million, and they seem to love to take marks off when you don't do this. Kilograms. Anyway, it's just saying make sure you use the units, okay? So now that we've done that, let's go on to another question, which is exactly the same. Calculate the quantity of butter demanded per year when price is $10, okay? So what we have here is we've got quantity demanded, like always, equals 420 minus 19p. And here I'm going to write P equals, I'm going to do my dollar symbol better, yeah, 10. Okay, so how do we find the amount that people buy? Well, we know the price is 10. We know the equation or the function, so it's 420 minus 19, and price is 10, so instead of P, I'm going to put in 10. Okay, so quantity demanded, I don't need to get my calculator out for this one because 10 times anything you just add is 0, so it's 190. And then I will, just for the sake, I even have the answer written down here, but you might as well show what I'm doing, is 230. And if quantity demanded equals 230 million kilograms. Okay, so I would hope that you would understand that, as you can see here, as price rose from 7 to 10, the quantity demanded, the amount that people bought, fell. Okay, so that's, I hope that makes sense. I really, really do. Okay, now, the next thing it says, from the equation, right, given above here, right, it's 420 minus 30p. It is a different equation. It's a different country. This one was Ruritania up the top. This one here is Zestria. Okay, so from the equation, find the slope. Well, I tried to write things down to kind of give you a bit of reminder and stuff. The slope is the number before P. Okay, now look, very technically, I don't want to get into this too much, right? But price is on the vertical axis, quantity is on the horizontal axis, all right? And it should be y equals mx plus c. All right, this is technically the inverse of the slope, but for the IB, they want you to measure it as the change in P over the change in Q. Okay, so all we have to do, so the quantity demanded equals 420 minus 30p. What's the number before P? 30. Well, that's incorrect. Okay, it's half right. The number before P is minus 30. Remember that slope can go up or down, and the minus or a plus, you have to write that down. Now, for a demand curve, certainly if it obeys the law of demand, it will always be a minus. For a supply curve, it will always be a plus. And again, that's for the curves that obey the laws of supply and demand. Okay, now we're on to 3b, and just make sure you can see that, and I believe you can. Calculate the price at which monthly quantity demanded will be 210 units. Okay, right, well, what we've got to do here now is I've got to find, excuse me, I've got to find the equation again, so it's 420 minus 30p. Okay, sorry, it's here. I should do that. It's 420, QD equals 420 minus 30p. Okay, so I'm going to write that down here. So quantity demanded, and I'm trying to keep everything straight so you can see it, equals 420 minus 30p. Okay, now this is the difference here. So QD, we have to find the price. So QD equals 210 units. So instead of changing price, now we're changing quantity. So we have 210 equals 420 minus 30p. We don't know the price, we're trying to find the price, okay? Well, what I'm going to do now is I'm going to do them both at the same time. I'm going to bring the 30 over here, so that cross the equal sign, that changes its sign. It was a minus, now it's a plus. And we have 420 on this side, and I'm going to bring this over here, which is minus 210, okay? So then what we've got here is 30p equals 420 minus 210, which I also believe is 210, okay? So now what we do is we divide both sides by the number before the letter we're trying to find. The letter we're trying to find is P, the number before it is 30. 30 divided by 30 cancels out, so we're left with 1P, which is what we want, and 210 divided by 30, well, the 10s cancel, and 21 divided by 3 is 7. So basically our answer is P equals $7, okay? Now, calculate the price at which monthly quantity demanded, just making sure we can see it here, yeah, monthly quantity demanded would be 60 units. Well, again, what we're going to do is always start off by writing down the equation. At least that's what I think. I think there's less of a chance of making a mistake if you write down the equation. And here we're writing QD equals 60 units. Okay, so what we're going to do is we're going to put 60 in here equals 420 minus 30p. Okay, I'm going to bring the 30 over, make that plus 30p equals 420 minus 60. Okay, because it was a plus, now it's a minus. Okay, sorry, I should really be doing this on the camera. 420 minus 60 equals 360. So we've got 30p equals 360. Okay, so what do we do? Well, just simple algebra, divide both sides by the number before the letter you're trying to find. 30 divided by 30 is 1, so we get 1p, which is what we want, and 36 divided by 30, and I do believe that's 12, and thank God I'm right. Okay, so we come up along here, and we write p equals $12. Okay, now not doing too badly. Okay, now this is where it gets somewhat difficult. Okay, this is where it gets well, slightly, a little bit difficult. Okay, so we're not going to stress about this, right? But the first thing it has to say is, right, label the axes on the grid. Okay, well, in order to label the axes on the grid, all we have to do here is write price. Okay, so I'm going to get out my pencil now. Okay, so price on this axis and quantity on this axis. Okay, now just to make sure, and we're going to have to go back to this page here, but just to make sure, okay, monthly demand is given by this, our quantity per month and P, right? So QD equals quantity per month. We don't need to worry, it's not in millions or anything like that, so absolutely fine. Okay, now, so we've got this. So we have answered question 3D, which is label the axes on the grid. What we've got is price and quantity. Okay, no problem there. And the monthly demand for good X. Okay, so the price, if you want a little bit more of good X and quantity per month of, hope you can see, good X. There we go, no problem. Okay, that's a bit of overkill, but you know, there's no mad issue there whatsoever. Okay, now it says here, construct the demand curve, okay, for good X on the grid. Well, you see, the funny thing that we've got here is, okay, what we've actually got is we've got 2 points. We've got 2 things that are on the grid. We've got 2, well, it really is points, a collection of price and quantity and a collection of price and quantity. So we know that at a price of 7, quantity demanded is 210. Okay, so if I go 6, 7, all right, 8, 9, 10, you can see that. So this here is 7, okay, okay, and if I go out from 220, 40, 60, 81, okay, well, I tell you what, I'm not going to do that for the reason is that that's not entirely precise. And let's have another look here. Okay, not that one, using the wrong sheet of paper. Okay, so this one here is 12 and 60. Well, now 60 should work, and 60 does. Okay, so here's one. So we've got 60 and 12. So we go from there, 11, 12. So there's 1 point, okay? So what we're going to have to do now is we're going to have to work out another point, right? Now, a great one to do really is this, is when you set price equal to 0. And what that will tell you is the quantity, where it cuts the quantity axis. So if we set price equal to 0 for this one here, and again, I'm trying to remember what is it? Excuse me. It is 420 minus 30p. You must forgive me. Okay, so I'll do it here. So we've got 420. Okay, so we've got QD equals 420 minus 30p. Okay, so if we set price equal to 0, all right, we'll find the quantity that will be bought if the thing is given away for free. So it's a P equals 0. So we've got QD equals 420 minus 30 times 0. QD equals 420 minus 0. QD equals 420. So this is something that I really want you to see, and I think you can. Okay, this is something that I really want you to see, is that it's always, when you set price equal to 0, it's always the number on its own. Okay, so now we've got, this is 420, 440, 460, 480, yeah, so here. So now we've got 2 points on the curve. So what do we do? Now, obviously, I suppose do what I say, not what I do, really, and try to keep your dots small and your pencil sharp. Okay, but let's see. So where's this going here? This is going to 11, 12, 13, 14. Okay, so this is going to 14. Well, let's check that out. Okay, so at a price of 14, if we put in a price of 14 here, quantity demanded should be 0. Okay, so let's check that out. Okay, now I do it in pen just to be sure. Okay, quantity demanded equals 420 minus 30 times 14. Okay, so we're going to go quantity demanded equals 420 minus, and we go here, 30 times 14 equals 420. Surprise, surprise, 420. Quantity demanded equals 0. So what we're saying is at a price equal to $14, quantity demanded equals 0. And that's what we found there. Now, there are a number of ways of working this out, okay? There are a number of ways of working this out, but all you essentially need to do, of drawing a line, but all you essentially need to do is to find 2 points that are on that curve, that are on that line. And basically, right, if you're very unsure about math, okay, this isn't hard. All you have to do is put in any price that you see kind of listed along here somewhere, and most likely you'll get a point that you can just put a dot in that grid, in this grid here, okay? So any point that you put into that function, the 420 minus 30p, for price, you'll get a quantity, and then that's a dot that you can put it on the curve, all right? So it really isn't difficult. Back yourself absolutely 100%, okay? Now, don't forget, all right, the curve was QD equals 420 minus 30p. Now what we're saying here is outline why the position of demand curve above will change if the demand function changes to this. So what is the difference? And I will write it here. It was QD equals 420 minus 30p. Okay, don't forget the number before the p is the slope. Okay, so that hasn't changed. So the slope is going to be the same. All right. And what we're actually saying is the demand curve, because this number, the function, the part on its own, okay, changes. So instead of touching here, which is 420, it's going to touch here. Okay, now that's not just true for that. For every other price, it's going to be further out. And how much further out is it going to be? Well, it's going to be 80 units to the right. How do I know that it's increased 80 units to the right? How do I know that the demand curve has shifted out? Well, if we compare these two numbers, that means the slope hasn't changed. So it's got to be parallel. It's got to be the exact same slope. And all we're saying here is that it's moved. This has increased the number on its own, autonomous consumption. Well, it's not really, but it's consumption irrespective of price. Consumption that would occur if price was 0. Because this has increased by 80, the demand curve will shift to the right. By how much? 80 units at each price. At every single price, 80 units more will be purchased. Why? Because the quantity demanded has increased by 80 units at each price. Whatever the price was, this is 80 units bigger than that. Okay, and that's why. If this here was, what's 80 units smaller than that? 340, I believe, forgive my maths, but then that means that the demand curve would have shifted inwards by 80 units at each price. If this was 100 units less, so this is 320, the demand curve would have shifted in 100 units. If this was 100 units more, like 520, the demand curve would have shifted out 100 units at every price. At every single price, more would have been purchased. Okay, and that's all you have to write down. The demand curve will shift to the right by 80 units at each price because the quantity demanded has increased by 80 units at each price. Okay, that's all you have to write for that. Now, have I covered all of that? Yes, I have. Okay, again, forgive me trying to be quick. Okay, outline how the steepness of the demand curve will change if the demand function changes too. So, right, we're back to 420, but what we were originally was QD equals 420 minus 30p. And this is what I need you to see here. And a lot of people think, oh, the number gets bigger, so it's going to get steeper, right? Now, more on this when we come to PED. But it's no, actually. The demand curve will become less steep, okay? All I'm saying is it'll become shallower or flatter. The demand curve will become shallower or flatter. Now, why? Well, I'm going to keep these numbers visible. Okay, so instead of every time the price goes up by 1, quantity demanded falls by 30, now every time price goes up by 1, quantity demanded falls by 40. Okay, that's what I need you to see. So this is because for any change in price, 1 in both cases, the change in quantity demanded will now be greater, and hence the curve will have to be flatter, okay, to show that. So that's all we're saying there. I really, really hope that helps. Thank you so much, and